Hello everybody, Devashish again from Dev's Learning Hub. So our today's session is another interesting one of coordinate geometry, second class. In the first class itself, I have already covered the concept of coordinate geometry. What is the difference between geometry and coordinate geometry? क्या होता है ये दोनों का बीच में difference क्या है, right? उसका बाद क्या है, coordinate का मतलब क्या होता है? What is the actual concept of coordinates? Dimension क्या होता है? What is the implication of dimension in coordinate geometry? And how it is related to the number of axes, right? How dimension is related to the number of parameters or number of axes? What is quadrant? और quadrant का हर quadrant का साथ ये coordinate कैसे change होते जाता है, right? So all these important topics I have covered, the conceptual things I have covered in the first class, right? The second class, what we are I am going to cover today, it is given a point and given a straight line, you need to find out whether this point is on the given straight line or not, right? Second one is equation of a straight line. What is the generic form of a straight line in algebraic expression? I have already given that expression already in my first class. It is y equals to mx plus c, but I will explain that one in more detail in today's class. The third one is derive equation of x-axis and parallel to x-axis, the line parallel to x-axis, and also derive the equation of y-axis as well as any line that is parallel to y-axis, right? So these are the things I am going to cover along with few of the examples also. Okay, so let's start with the point number one. Okay, number one topic, point on a straight line, yes or no. If a given straight line equation, if a straight line equation is given 3y, here it is 3y equals to 2x plus 2, then which of the following points lies on the above line, right? So you need to find out which of the points actually lies on this line. That means this, first of all, this is an equation of a straight line because it's a linear equation with two variables, right? So it is a straight line equation which has two dimension, length x and y, right? So x is, if you remember, if you go through the first class, for what the link is given in the description section below for this particular video, you will understand how you will able to find out just by looking into the equation whether it's an equation of straight line or not, right? So now let me just quickly draw the axis for on a plane. So that is a two-dimensional x dot y dot. So above x-axis x dot y is positive, below x-axis y is negative. Similarly, right side of x, this is positive, right side of y-axis it is positive, x is positive, and left side of y-axis x is negative. Therefore, if you move towards the anti-clockwise direction, the x and y coordinate, what will be the sign? Here it is x positive, y positive, both are positive. So in the second quadrant, x is negative, y is positive. Third quadrant, y below x-axis, below origin, this is origin, right? So y below origin, x is also left side of y-axis. So it is, both are negative, negative, negative. And in the fourth quadrant itself, this is the first quadrant, second quadrant, third quadrant. Fourth quadrant, x right side of y-axis, that is positive, and y is below x-axis or below origin, that is negative. So that is how the coordinate signs are there, right? Now, it's no way related to this particular question, by the way, but still, just to recapitulate, you need to remember that because I will ask immediately after this, in which quadrant this point belongs to. If any of the point lies on the straight line, in which quadrant it belongs to. So, if a point lies on a specific straight line, that means the coordinate of the point, x-axis, y-axis, x coordinate and y coordinate, if you put that x coordinate and y coordinate in the equation, the value that should satisfy that equation, right? So what is the equation here? Here the equation is 3y equals to 2x plus 2. Now what is the value of x and y here? In the given condition, x equals to 3 and y equals to 2. Now we replace these values. So 3y equals to 3 into 2, that is equals to 6, right? And 2x plus 2 equals to 2 into 3 plus 2, that is equals to 8. That means 3y and 2x plus 2, these two are not equal. These two are not equal. That means 3 and 2, this doesn't satisfy this equation. That means it is not on the given line 3y equals to 2x plus 2. Now let's check for the second point. 3y equals to, here x equals to 5, y equals to 4. So 3y equals to 3 into 4, that is equals to 12. Where and 2x plus 2, 2x plus 2, that is equals to 2 into 5 plus 2, that is also equals to 12. That means the equation 3y equals to 2x plus 2, these two values are equal, right? Both the cases it is 12. 3y is 12, 2x plus 2 12, so 3y equals to 2x plus 2. This satisfies this particular point 5 4, it satisfies this equation. That means it is on the given line. So that is how you need to check whether a given point is on a given straight line equation. If it is satisfying that equation, that means it is on that straight line, otherwise it's not. So point number 1, it's done. Very simple. Okay, so now let's understand what is inclination, slope and intercept. If the equation of a straight line y equals to mx plus c, this is the linear equation with two variables x and y. So what are these aim? Aim is the slope or gradient of that line, and c is the y-intercept. Now let's understand what is slope, and before understanding slope you need to understand the inclination. Okay, okay. Now look into this lines L1 and L2. This is x-axis, this is y-axis. So intersecting point O, that is the origin, and what is the coordinate for origin? That is 0 0. That means both x and y coordinate, here it is 0 0, because from here right side x is positive, left side x is negative. From here y upward it is positive, and ordinate y downward it is negative. So this point both x and y is 0. Now let's say for L1, line L1, inclination is the angle made by the straight line with positive direction of x-axis. What does it mean with the positive direction of x-axis? Or the angle that is towards anti-clockwise direction. What does it mean actually? Let's say the line is here on the x-axis. This is lying on x-axis, right? Now this line is moving anti-clockwise direction. So now this is the position. This is the line L1, right? So it is moving anti-clockwise direction. So it is anti-clockwise direction, right? So this anti-clockwise direction is made by the line with positive direction of x-axis, because anti-clockwise direction could be this one also, because when L1 is intersecting x-axis, it is creating this angle is also with x-axis, and this angle is also with x-axis. But this angle is not with the positive direction of x-axis, because positive direction of x-axis is right side towards this side, and negative direction of x-axis because x is becoming negative towards this direction. So this angle is the angle of L1, line L1, with negative direction of x-axis, whereas this angle is the angle with positive direction of x-axis. So if I say this is theta, this angle is theta, and this angle is, let's say, alpha. So what is the inclination? Inclination is not alpha, inclination is theta, because theta is the angle made with the positive direction of x-axis. Okay, So now let's say for L2 also similarly it is this direction with the positive direction, not this angle, because this angle is also with x-axis, this angle is also with x-axis, but this one will be the inclination because this is with positive direction of x-axis. That is what you need to remember. That is how the entire all the formulas, all the concept building that is done based on this assumption. So always let's assume the x-axis is moving anti-clockwise in the anti-clockwise direction. So the x-axis, the line on the x-axis, not x-axis, the line on the x-axis that is moving towards anti-clockwise direction, and the angle made with the x-axis, the angle of the line with the positive direction of x-axis, this is inclination. So now let's say there is another line. Let's say there is another line. This is one line, L3. This line is L3. Here with positive direction of x-axis the angle is this one, because this is the right. In this case the theta or the inclination, that is actually obtuse angle. So inclination it could be, and when it is on the x-axis the inclination is 0 degree, because with the x-axis there is no angle. Then it is increasing. It could be 90 degree, it could be less than 90 degree, it could be more than 90 degrees. So it could be acute angle, it could be equal to 90. It is when it is the line is lying on the y-axis, then the inclination, when this angle is, let's say this line is moving, this line is moving, and finally this line is coming on the x-axis. So in that case the line will lie on the y-axis, right, towards y-axis. So when it is on the y-axis, the angle with x-axis, positive direction of x-axis, is 90 degree. So inclination could be acute, that is less than 90 degree, obtuse, that is greater than 90 degree, equals to 90 degree, or equals to 0 degree. So this is what the definition of inclination. Now what is slope? Slope is commonly denoted by m, small m. M equals to slope, that is equals to tan of the inclination. If the inclination is theta, that is the angle made with the positive direction of x-axis theta, then the slope will be tan theta. So that is what m. So m is tan theta. So if you know the theta value, and then you can find out the slope. Now what is C? C, this is a y-intercept. Let's say for line L1, where it cuts y-axis at this point. So on y-axis you have y coordinate value you have, but x is 0. So the coordinate of this point will be, let's say this distance is this distance where it cuts the line L1, where it cuts the y-axis, intersects the y-axis. So the portion between origin up to this portion, this is, let's say, C. So therefore the coordinate will be here x coordinate 0, y coordinate is C, because C is in the positive direction. For line L2, this is 0 minus C. C is, y is negative at the right, downward direction, right, from origin. Here it will be minus C. So C value could be positive or negative. This is called y-intercept, where it intersects y-axis. That the portion between origin and that point is called y-intercept, and where it intersects x-axis, that is called x-intercept. So if we say this point, intersection point for with x-axis is A, intersection point with y-axis it is B, and the origin is O, in that case OA is x-intercept and OB is the y-intercept. So now it's clear to you. So when it is the general form of a straight line equation M and C, M is the gradient of slope. Slope is nothing but the tangent of inclination, and this value of inclination always measured in the direction anti-clockwise direction and with the positive direction of x-axis, anti-clockwise direction and with the positive direction of x-axis. Because when I say for line L2, let's say for line L2, this is also with positive direction of x-axis, this angle theta, this is also positive direction of x-axis, and this beta, this is also with positive direction of x-axis, but this theta is towards anti-clockwise direction. So there are 2 points. The inclination is the angle made by the straight line with the positive direction of x-axis in the anti-clockwise direction. Both of these are the keywords. The angle made by the straight line with positive direction of x-axis. So the angle between positive direction of x-axis and the straight line and measured in the anti-clockwise direction. This is very important to understand inclination. If you understand inclination, you can find out the slope easily. Okay, now look into this tabular data. First column heading is line type. Second column is equation form. For each line type, what will be the equation? Next is, what is the inclination of the line? Inclination means, as I said, inclination with x-axis in the anti-clockwise direction. And then what is the slope? So the first one is line type slanted. Slanted may, and the equation form is y equals to mx plus c. That means slanted means this line is not parallel to x-axis or y-axis. This is intersecting both x and y-axis. That means it has both x and y intercept. Okay. So this is x-axis, x dot, y and y dot. Okay. So now let's say there is a line. This is intersecting y-axis here, right, at the point B, and intersecting x-axis at point C, and the origin it is O. That means OB is the y-intercept. OB is y-intercept. OC equals to x-intercept. And this is the angle in the anti-clockwise direction it's creating with x-axis. I'm assuming this angle is theta, right? So in that case, if it is theta, that means the slope will be, inclination is theta, slope will be m. Conventionally we consider m as the slope, right? M equals to tan theta. And what is m actually? M equals to OB by OC, because this is 90 degree, because both x-axis and y-axis intersects each other at 90 degree angle. So it is 90 degree. That means it is perpendicular by base. OB is the perpendicular, OC is the base. So OB by OC. Right? And this tan theta is the slope. So slanted y equals to mx plus c, the equation of the line is, the equation of this line is y equals to mx plus c, where m equals to tan theta, and this OB I assume this is this y-intercept, it is c. Actually in the equation y equals to mx plus c, we consider this c as the y-intercept. This y-intercept could be in the positive y-axis or in the negative y-axis. Let's say the line is cutting in this manner. In that case, this c will be negative. It is cutting the y-axis in the negative part, right? So y equals to mx plus c, where it intersects both x and y-axis, right? So tan theta is the slope. Now I'll come to the x-axis equation. Okay. Now if we assume the line is actually lying on the x-axis. On the x-axis, that means x-axis itself, the equation of x-axis. So it is not creating any inclination with x-axis. That means the inclination value, that is theta, that is equals to 0 degree. If theta is 0 degree, that means m equals to tan theta is tan 0 degree. What is the value of tan 0? That is 0. So value of m is 0, and it is not intercepting the y-axis because it is just the x-axis. That means there is no intercept. That means c is also 0. So in the equation y equals to mx plus c, if you have m equals to 0 and c is also 0, that means the equation is y equals to 0. So the equation of x-axis is y equals to 0, c equals to 0 and m equals to 0. So this is the general equation, right, of a straight line where both it has x-intercept and y-intercept, right? So inclination is 0 degree theta and the tan theta slope, that is also 0. Next is parallel to x-axis, not x-axis but parallel to x-axis. So now if this is the axis, this is x-axis and this is y-axis, and parallel to x-axis it could be here, or that is on the first and second quadrant. The line can pass through first and second quadrant, or the line can be pass through the third and fourth quadrant. What is the parallel to x-axis means? The distance from x-axis will be equal. That means it is intersecting the y-axis and therefore the y-intercept it is there, but across the line the intercept always it is equal. Here also what is the distance? Here also the same distance. Here also it is the same distance. So if it is parallel to x-axis, I am assuming the distance between x-axis and that line, it is y. That means, it is k. That means I am assuming this y-intercept, this is the y-intercept, right? This portion is the y-intercept because this is the origin. If it is the origin, this, let's say intersecting, here it is B and here it is C. That means OB and OC, these are actually y-intercept for the line. So what is the value of that? I assume the value of that constant distance, it is k. That means the y-intercept C equals to k. And what is the value of m? The value of m, that is equals to 0, because whether it is x-axis or parallel to x-axis, both the cases there is no inclination with the x-axis because it is not intersecting x-axis. Therefore the theta inclination is 0 and therefore the slope m equals to tan theta, that is also 0. So therefore c and k, both of these values I got it here. So m equals to 0, c equals to k. Now you put this value here, y equals to mx plus c, y equals to mx plus c, where m is 0, therefore mx, this portion is 0 plus c is k. So y equals to k. This is the equation. So parallel to x-axis, y equals to k, where m equals to 0, c equals to k. Inclination is 0 degree and tan 0 is 0, that is the slope. Similarly, but for y-axis, you cannot achieve it from this y equals to mx plus c formula. For all the cases, we can achieve from y equals to mx plus c, but here you cannot. Why? So, if the line is lying on y-axis, let's say if the line is lying on the y-axis, that is equivalent, that is it's the y-axis itself, right? So the angle with x-axis in the positive direction, it is 90 degree. That means inclination theta equals to 90 degree. If inclination theta equals to 90 degree, that means tan theta equals to tan 90 degree. That is equals to undefined. Tan 90 is undefined. Therefore, you should not utilize this y equals to mx plus c formula for y-axis or to find out the equation of y-axis or parallel to y-axis. But then in that case, how will you find it? You will find in this manner. If it is parallel to y-axis and the line is passing through second and third quadrant, that means the distance is always equal. I assume this distance, that means distance from the origin, right? Distance from the origin, distance from the y-axis, right? So for this particular y-axis, it is, I'm not talking of, I should let me first find out the equation of the y-axis. So for y-axis itself, what we can see, that it is on the y-axis, that means here x equals to 0. This is on the y-axis, that means there is no abscissa or there is no x coordinate because it is on the y-axis. So x coordinate, there is no value as such, right? X value, that is 0 because it is passing through origin and on the y-axis. So what is the coordinate of origin? It is 0, 0. So x equals to 0, that is the equation of y-axis. X equals to 0, that is the, because y is moving, y, the value of y at different points on the line is different. Here it is one value of y, this is another value of y, this is another value of y. So y is varying, but x is always 0. So therefore we can express this y-axis as x equals to 0. Now if it is parallel to y-axis, in that case also the x is always equal, but it is not 0. The value of x everywhere it is same. Let's say if it is k, it is also k. That means parallel to y-axis, it will be x equals to constant. So I am not utilizing the formula y equals to mx plus c, just to understand, because when you are on the y-axis, different points, or there could be, this point could be x0, y minus 3. This point could be x0, y minus 2. This point could be x0, y 5. So along the y-axis, x is always 0. Y, value of y coordinate is varying. Similarly, for parallel to y-axis also, the y value is varying across the line, along the line. But the value of x, it is not 0, but it is constant. Therefore, x equals to k, k is the constant value. So therefore, you see here, y-axis, it is x equals to 0, equation is x equals to 0. The inclination, it is 90 degree. And the slope is undefined, therefore we cannot utilize the formula y equals to mx plus c to find out the slope, right? to find out the equation. So parallel to y-axis, it is not x equals to 0, but x equals to k. Sorry, it should be x equals to k, where k is the value of x coordinate along the line everywhere. Okay, so slope is as usual, the inclination is 90 degree and slope is undefined. So now all the topics I have covered today and tried to explain very clearly. So if you like this video, please click on the like button, and if you are really interested to have this kind of video again and again to make your fundamentals clear, please subscribe my channel, Dev's Learning Hub. Thank you very much.